Welcome back, everyone. In this video, we're just going to go over page 4 of the Unit 4-5 notes. It's my hope that this video goes a little bit quicker than the last, so let's get moving. So we're going to apply the Laplace transform to both sides. So here we have the Laplace transform y double prime plus 4y must equal the Laplace transform of the right-hand side 4t squared minus 4t plus 10. Okay, the left-hand side, we've seen the Laplace transform of y double prime. It's s squared capital Y of s minus s times little y of 0 minus little y prime of 0. Now the Laplace transform of 4y is 4 capital Y of s. And then on the right-hand side, the Laplace transform of 4t squared. Well, we look at the chart and we see the Laplace transform of t squared is 2 over s cubed. So we need 4 times that, so we get 8 over s cubed, right? Minus, and now the Laplace transform of t is just 1 over s squared, so we get 4 over s squared, right? And now the Laplace transform of a constant is just that constant divided by s. All right, so let's see here. If we now simplify this, we get the following, that y of s times s squared plus 4 is going to be, well, little y of 0 is 0, so this term actually vanishes. And I just get minus 3 equals 8 over s cubed minus 4 over s squared plus 10 over s, right? And now I'm going to add 3 to both sides. So this says that y of s times s squared plus 4 equals 8 over s cubed minus 4 over s squared plus 10 over s plus 3, which I'm actually going to find a common denominator of, which is s cubed. And you'll notice that 8 does not need to change. The 4 needs an extra factor of s, right? In order to get an s cubed, I need an extra factor of s. This one needs 2 extra factors of s. And the 3 needs 3 factors of s. So that's why I get a 10 plus 10s squared plus 3s cubed. Okay. And so what that tells me then is therefore that y of s, just divide both sides by s squared plus 4. I'll just keep it in the order that it's in. You can write it in descending order if you like, the numerator that is. Okay, so we get something like this, right? And now what do we need to do? Well, we need to decompose according to partial fractions, right? So that means we're going to get an a over s cubed. Notice this right here is a repeated linear factor. It's repeated 3 times. So I start with an a over s cubed, and then a b over s squared, and then a c over s. Now I'm down to the first power, so I'm done with that. And then I go plus ds plus e over s squared plus 4. Okay. And now we are going to recombine this into a single fraction. But let's just work with the numerators. So on the left-hand side, I get the numerator 8 minus 4s plus 10s squared plus 3s cubed equals, now let's see what the numerators would be. Well, if my common denominator is going to be s cubed times s squared plus 4, then what does the a need? Maybe you can answer this aloud if you like, or pause the video and work on this yourself. But I think the a just needs the s squared plus 4. What does b need? Well, it also needs the s squared plus 4, but also 1 extra factor of s, right? C needs the s squared plus 4, but 2 factors of s. And then ds plus e, it already has the s squared plus 4, so it needs the s cubed. Okay. And now what I'm actually going to do is I am going to kick it old school and do this the Calc 2 way, just to show you that it can be done that way as well. And in fact, I think for this one it's probably easier to do that, since there are no, other than s equals 0, there are really no good s values that'll like knock out a whole bunch of terms. So what I'm going to do is find all of the coefficients. So I think the highest power of s we get if you would expand all this out is s to the fourth. And so what's the coefficient of s to the fourth? Well, you get a c times s to the fourth, and then there's also a d times s to the fourth, about s cubed. Well, I think there's a b plus e, s squared. I think there's going to be an a plus 4c. Notice here's the a, and then we have cs squared times 4, so 4c. Then the s, we get just a 4b. And then the constant term, the only thing that does not have any dependence on s is actually just a times 4, so 4a. And now what we're going to do, you'll remember how it goes, equate coefficients. So the constant term 8 has to equal the constant term 4a, so a has to equal 2. The coefficient of s, which is minus 4, has to equal the coefficient of s here, which is 4b, so b is minus 1. Okay. The coefficient of s squared, which is 10, has to equal a, which I know is 2 plus 4c. Oh, well, that's easy. That tells me then that c also equals 2, right? Subtract 2, divide by 4. Let's look here. The coefficient of s cubed, which is 3, has to equal the b value, which I know is negative 1, plus the e value. And so e must be 4. And then finally, the coefficient of s to the fourth, well, there is none on the left-hand side, so there's 0 of them, has to equal the coefficient of s to the fourth here, which is the c value plus the d value, so 2 plus d, and so d is minus 2. All right, so y of s then equals this decomposition right here. So a, which is 2 over s cubed, plus b, which is negative 1 over s squared, plus c, which is 2 divided by s, plus, and then negative 2s plus 4 all over s squared plus 4. And if you like, since we know that this is going to split up as a sine and a cosine identity, why don't we go ahead and do that? All right. So what that tells us then is that little y of t equals the Laplace inverse of 2 over s cubed minus the Laplace inverse 1 over s squared plus the Laplace inverse of 2 over s minus the Laplace inverse of 2s over s squared plus 4 plus the Laplace inverse. And now here, what is our b or beta value? I think it's 2, right? Because it's what number squared gives you 4? Well, 2. And so that means I need a factor of 2 on top. Well, thankfully 4 is 2 times 2, right? And so it's always good to start adjusting accordingly as you can. And now just go through, find all these Laplace inverses. I think they're all pretty easy. If you look on the right-hand column, 2 over s cubed, its Laplace inverse is just t squared. 1 over s squared, its Laplace inverse is just t. 2 over s, its Laplace inverse is just 2. Now this one, the s over s squared plus 4, is the cosine of 2t, so I have 2 cos 2t. And then here, this 2 divided by s squared plus 4 is the sine of 2t, but I have an extra factor of 2 there. And there we go. All right, that's it for this one. In the next video, we learn about some interesting properties of the Laplace transform.